Google searches your name. In the top right sidebar, a little box. Your job, your employer, your dates. Where did that box come from? Not a database somebody typed up. Not really. It came from a system that read the whole web and pulled structured facts out of unstructured sentences. Millions of triples, extracted, ranked, cross-checked, published. The knowledge graph. And that pipeline has a name: information extraction. Welcome to video 4 of lecture 9, information extraction. The messy, unglamorous engine that turns pages of text into rows of structured data. Every recommender system, every knowledge graph, every enterprise search, every LLM that grounds itself in real facts. There's an IE pipeline under the hood. Let's look at what it actually does. Video 3 closed with RAG, retrieve documents, generate answers. But retrieval returns paragraphs. What if you want a single fact? The founding year, the CEO's name, the drug dosage. You could ask the LLM to read the paragraph and extract it every time. Slow, expensive. Or you could extract that fact once, upstream, into a structured knowledge base. That's information extraction. Today's puzzle: how does anyone extract accurate facts from billions of sentences when the writers don't follow templates? Every article says the same thing differently. Founded, started, established, launched, and half the time the entities are pronouns: she, the company, it. Turning that noise into clean triples is a stack of subproblems, each with its own long history. Today's 3 beats. First, relation extraction. Take a sentence with 2 entities. Decide what relation, if any, holds between them. Founded by, married to, located in. Classic supervised classification. Second, event extraction. Not just static facts, actions. Who did what to whom, when, where. Bombings, product launches, financial deals. Way harder than relations. Third, open IE and distant supervision. The scale tricks. Etzioni 2011, Mintz 2009. How to get from a hand-labeled corpus of 1,000 sentences to a knowledge base of 1 billion facts. Beat 1. Relation extraction. The classical setup. You already have named entities. Named entity recognition is lecture 3 material. We've covered it. Given 2 entities in a sentence, decide which of a fixed list of relations holds between them. Or no relation. It's classification. Features used to be POS tags and dependency paths. Since 2018, it's been BERT reading the sentence and producing a relation label. The hard part of relation extraction isn't the classifier, it's the labeled data. Somebody has to sit down and mark up thousands of sentences with, and this pair has this relation. That is slow. It is expensive. It's why the ACE program in the 2000s made a big deal out of releasing hand-annotated corpora. The entire field ran on those datasets for a decade. And it's why the next 2 ideas, distant supervision and open IE, became so important. Cheating on the labels. One more thing about relations. The set of relations is typically closed. You pre-declare. I care about founded by, employed by, located in, and 20 others. Sentences that don't fit those get dropped. This is fine when you're building a specific product. It's brutal when you want to discover new relations, which is exactly what OpenIE was built for. Hang on to that. Beat 2. Event extraction. This one is harder. A relation is static. X founded Y. An event is dynamic. X acquired Y on date D for price P. You have to detect the event trigger, usually a verb. Identify all the roles: buyer, seller, price, date, location, and assemble them into a structured record. This maps onto the semantic role labeling we hit in lecture 4. Same job, different framing. 2 things make event extraction brutal. 1. The arguments can be scattered. The buyer might be in one clause, the price in a footnote, the date in the headline. 2. The same event gets written 100 ways. Acquired, purchased, bought, closed the deal for, went through with the merger. You need a way to say, all these surface forms trigger the same underlying event type. In production, event extraction is a Coreference problem stacked on top of everything else. The company acquired its rival. Which company? Which rival? Coreference resolution. Figuring out that a company refers to Salesforce mentioned 3 sentences earlier is a whole separate subfield. And it's the thing that turns a fragmented extraction into a coherent event record. Beat 3. Open information extraction. Etzioni 2011 at Washington. Reverb. The insight. Stop pre-declaring relations. Extract every plausible subject-verb-object triple you can find. Let the vocabulary of relations be the natural language itself. So Barack Obama was born in Hawaii produces the triple Obama was born in Hawaii. No target schema. Web scale. Millions of relations. The other scale trick. Distant supervision. Mintz et al. 2009 at Stanford. The clever move, take an existing knowledge base like Freebase, which already has the fact Obama was born in Hawaii. Find every sentence on the web that mentions both Obama and Hawaii. Assume those sentences express the born-in relation. Use them as training data. Noisy, but free. And at scale, the signal outweighs the noise. Distant supervision changed the field. Google's Knowledge Graph, IBM Watson, and every enterprise ontology tool of the 2010s ran on some variant of it. And then, LLMs arrived. And now you can just prompt GPT-4 or Claude. Read this article, output every fact as a triple, and get decent extractions in one shot, which is either the end of the field or its biggest evaluation problem, depending on who you ask. 3 takeaways before the quiz. 1. Relation extraction. Classify a fixed relation between 2 named entities. Closed world. Needs labeled data. BERT-based classifiers own the modern benchmarks. 2. Event extraction. Trigger plus roles. Way harder than relations because arguments are scattered across sentences and Coreference has to hold it together. SRL from Lecture 4 is basically the same job. 3. OpenIE Etzioni 2011 and Distant Supervision, Mintz 2009, Unlocked Web Scale Extraction. Every knowledge graph runs on some variant. And LLMs may have just made the whole pipeline obsolete. Quiz 1. What is the job of a relation extractor? A. Generate new sentences given a knowledge graph. B. Given a sentence with 2 named entities, classify which relation, if any, holds between them from a fixed list. C. Translate a sentence from one language to another. Or D. Identify the language a document was written in. B. Take 2 already identified entities. Decide which of a pre-declared relation set fits. Founded by, employed by, located in, or no relation. Classic supervised classification. The hard part is the labeled data, which is why distant supervision and OpenIE became so important. Quiz 2. What was the key insight of Mintz et al. 2009's distant supervision approach? A. Train a classifier on a small manually annotated corpus and use active learning. B. Take an existing knowledge base like Freebase. Assume every sentence that mentions both entities of a known triple expresses that relation, and use those sentences as training data. C. Only train on sentences that a human has verified. Or D. Use a rule-based system instead of a learned model. B. Leverage an existing KB to generate free noisy training labels at web scale. Some sentences that mention Obama and Hawaii won't actually express born in, but at scale the signal beats the noise. Google's Knowledge Graph and every 2010s ontology tool ran on some variant of this. Quiz 3. What makes open information extraction, Etzioni 2011, different from classical relation extraction? A. OpenIE is faster because it uses a smaller model. B. OpenIE runs entirely on the client side without a server. C. OpenIE does not pre-declare a fixed set of target relations. It extracts every plausible subject-verb-object triple and lets the relation vocabulary be natural language itself. Or D. OpenIE only works on English. C. No fixed schema. Reverb, Ollie, and related systems produce triples like Musk, founded, Tesla, for whatever the sentence says. Trade-off. The same underlying fact shows up as many different triples: founded, started, launched, which downstream systems have to normalize. Back to the puzzle. Same fact, 100 surface forms. How do we handle it? A stack of subproblems. NIR, Coref, relation classification, event extraction, distance supervision, each with a 5-decade research history, and now an LLM prompt that might replace half of it. 4 applications down, 6 to go. Next up, question answering, the application that made IBM Watson a household name. Next time, question answering. IBM Watson beat the Jeopardy champions in 2011. 15 years later, every chatbot is a QA system. What changed under the hood? Hit subscribe.